Okay, so here we have a 100-gram bullet being fired into a 5-kilogram block that's sitting on a table that's 1.3 meters high, and we're told that the bullet becomes embedded into the block, or in other words, gets stuck inside the block, and as a result of the collision, as a result of the bullet being fired into the bullet block combo fly off the table with an unknown velocity and travel 2.8 meters horizontally to the ground. And from this information, we're asked to find the initial velocity of the bullet. So the thing to recognize here is that we have a collision. And whenever you see a collision, you know that conservation of momentum will apply. So the bullet collides with the block. We have a collision, so the concept that's going to apply here is the concept of conservation of momentum. And all conservation means is what you start with is equal to what you end with. So in equation form, up here we have, this is the initial momentum of object 1. Momentum is mass times velocity, plus the initial momentum of object 2 is going to equal the final momentum of object 1 plus the final momentum of object 2. Now, as I said a second ago, the bullet becomes embedded into the block. So the two objects become one, and that's referred to as a perfectly inelastic collision. That's the term for it, perfectly inelastic. And whenever you have a perfectly inelastic collision where the two objects become one, the final velocity of object 1 and the final velocity of object 2, these will be the same. It's the same velocity because the two objects have become one object. So this allows us to factor out v final. So this equation becomes m1 v1 initial plus m2 v2 initial, m1 plus m2. And all I did here is I factored out this v final because it's the same final velocity. Now in this problem we're told that the initial velocity of the block is 0. It's just sitting here. So we can put down here v2 initial is 0. It's just sitting there. Cross this out to 0. And we're solving for the initial velocity of the bullet. So from this equation here, so here is our conservation of momentum equation for the perfectly inelastic situation. So solving this equation for v1 initial gives m1 plus m2 v final divided by m1. So the only thing remaining to figure out is the final velocity after the collision, which is the velocity that the bullet block combo, so after the collision, the bullet is now in the block. We need to find this velocity immediately after the collision. And the way we're going to find it is by using our knowledge of projectile motion. So this basically becomes a kinematic problem. We have the vertical displacement, we have the horizontal displacement. This velocity that we're looking for as the bullet block combo leaves the edge of the table, that's an x velocity. And by the way, Vy initial, as the bullet block combo leaves the edge of the table, there is no y velocity to start with because the motion is only in the x. So basically, this x velocity right here is the velocity that we're going to be plugging in over here. It's that velocity. It's the velocity right after the collision. Okay, so let's figure out all the stuff we know for our projectile motion calculation. This 1.3 is our y displacement, and it's negative. Remember, our sign convention is plus, minus, plus, minus. So this 1.3 is negative because the bullet block combo travels down 1.3 meters vertically. This 2.8 is our x displacement, and that's positive. We know that our x acceleration is 0. And the reason for that is the x velocity does not change. This x velocity that we have as the bullet block combo leaves the edge of the table, that x velocity remains the same the entire way down. Vx does not change. And another way of saying that is there's no acceleration in the x direction. Now our y acceleration is gravity, which is negative 9.8. And gravity acts in the vertical. The y velocity is changing. We start out with no y velocity, but as the object flies through the air, we gain a y velocity. So we have y velocity there, and then a bigger y velocity. Vy is increasing. All right, so the way that we're going to find this velocity as the bullet block combo leaves the edge of the table, we're first going to solve for time. Time in air. And we're going to use the y direction. So the first kinematic is y equals 1/2 gt squared plus vy initial t. Vy initial is 0, so we can solve for t. T is going to be the square root of 2y over g. That's 2 times negative 1.3 divided by negative 9.8, which gives a time in the air of 0.51508. All right, so now that we have the time in the air, we can figure out what this x velocity was. So now we're going to go to the x direction. We'll go over here, and we're going to solve for Vx. So again, the first kinematic, x equals 1/2 at squared plus Vxt. There is no x acceleration. That goes to 0. So velocity x is x over t. Our x displacement is 2.8 meters. And our time is 0.51508 seconds. Oops, I made a mistake over here. That should just be seconds. Okay, so the x velocity as the bullet block combo leaves the edge of the table is 5.4361 meter per second. And then this gets plugged in up here. So that's our final velocity immediately after the collision. So m1 plus m2 is 5.1 kilograms. That's our total mass. We figured out the velocity after the collision to be 5.4361. And then m1 is just the mass of the bullet, which is 0.1 kilograms. So our final answer, the velocity of the bullet before the collision, is 277.2 meters per second.